Good afternoon, ladies and gentlemen. It's my honor to give you a talk about Medical God, a next-generation healthcare information system to support precision medicine. My name is Fei Lai. I'm from National Taiwan University. This is the outline of my talk. First, I will give you a brief description about precision medicine. Then, I will present our progress and result on electronic medical record and gene-related study. Then, I will describe our lifestyle and open environment data platform used for health-related study. This is the general picture of precision medicine. You can say as personalized health care. As a patient live with his or her family, and he communicated outside with smartphone and smartwatch. And this icon represents the living environment. And the three cornerstones of precision health, like gene, lifestyle, and environment here. And electronic medical record stands for his health status. Lifestyle include whether one do exercise regularly, take vacation once or twice a year, his political tendency, what he drink, eat, and how he travel to work, and also his religions, and for each day, how long and how far one walk, sit, and sleep, and also the quality is very important. Also, the sexy life is also important to one's health. And the other important factor including the working place and her social activity. These together constitute one's lifestyle. And the environment, like sunshine, air quality, water quality, and voice label. This constitute the environment part. Also, we have airbox installed in patient's home so we can get the local PM2.5 humidity and temperature value. Then, with the support from a hospital or medical center, we can get his complete electronic medical record. And with patient's consent, all this information can be uploaded to Health Cloud. And in order to provide service to our participant, we provide a service portal to patients. And with the assistance of my health bank from National Health Insurance Administration. We can correct all the health insurance related data like the drug, medicine information from other clinical or secondary opinions, hospital, or drugstores. All this will be transferred to our health cloud. And in order to survive, we need to have some partner like insurance company, patient support group, location-based service, and target medicines. And the study line here related to data and information flow. The dash line stands for service, and the dot line stands for alliance. Then I will give you our result on electronic medical record firstly. The objective of our work is to save the lab quality of coder. So we try to build an automatic ICD-10 coding and training system by deep learning method. That means that we will transform all the free text into ICD-10 code, including the diagnosis and the procedure code. ICD-10 stands for the International Statistical Classification of Diseases and Related Health Problems, 10th revision. And the left-hand side is the code for clinical modification, and the right-hand side is for the procedure coding system. We will take a brief comparison between ICD-9 and ICD-10. Since it increased a lot of code for both procedure and diagnosis, so it's a little bit complicated. Then ICD-9, the detailed coding rule. For example, G55.2 is a billable ICD code used to specify diagnosis of failed school examinations. And this is our experiment. We use the data that has this kind of problem. First is unbalanced, then it's a multi-labeling. Of course, it has a lot of mission value. And the data duration is from 2016, January the 1st. This is the first day of Taiwan adopt ICD-10 to 2018, August last day. And we have around 14,000 diagnosis code and about 10,000 procedure code. And the data was divided into training and validations. For the training data type, we include tube complaint, progress, history, pathology report, physical examination, discharge diagnosis, also ICU diagnosis. And we also have our testing result from the Far East Memorial Hospital. And we have around 10,000 diagnosis code, around 7,000 procedure code. And we have new training type like a chip complaint progress history, comorbidity and complication, special examination, discharge diagnosis, also surgical method. And totally for discharge diagnosis, we have around 245,000, and the unique words is around 15,000. And for the maximum length of discharge diagnosis is 306. And we use traditional approach like water vector. So we can understand the relationship between each word. For example, for a 100 dimension vector, the liver will be represented as this vector. In order to understand dynamic relationship between each word, like we considering the context, we use the BERT to do the feature extraction. BERT represented by directional encoder representation from transformer. For example, my God and Helmi God. These two gods is a little bit different. It depends on its neighboring word. Also, we need a lot of computing power. For example, like cloud tensor processing unit. We need both software algorithm improvement and we also need new hardware too. For combinational code, we use the preprocessing with conditional statement to do the transfer, like for example, hypertension plus chronic kidney disease plus heart failure, I-10 plus N18 plus I-50 will be combined into I-13. And the medical history help us any omission of chronic disease in the chart diagnosis. And this is the statistic about the medical history. We also take advantage of the ICD-10 definition. That means we pre-transfer model fine-tune with ICD-10 definition. And in order to process procedures, we take into account the surgical method. Okay. Also, the spatial examination. And the spatial examination include ultrasound, radiological examination, endoscope, electroencephalography. And this is about the result our effort for diagnosis prediction with BERT, our F1 score can reach 0.830. And for the procedural prediction, our F1 score is 0.700. It's much complicated for procedure prediction than diagnosis predictions. This is our website for you to take a try. The URL is next.csie.ntu.edu.tw. You are welcome to try. You can put a discharge diagnosis and you can set a threshold, and then it will generate the suggested diagnosis order in the score. And this system can also be used for newcomer training based on attention model. For example, you have diagnosis here, and if you put R9 2.0, and the related wording will be highlighted in yellow. So the training can understand why we have R92.0 here. We also build some rule-based approach to embrace the traditional approach of each hospital. Also, there are still some problem because of the rare cases. For example, there are 4,000 ICD-10 code appear only once. So it's difficulty to run this kind of case. Also, there are spelling error, coding standard not built, abbreviation not recovered, standard terminology not used. So that's increased the complexity. And sometimes we don't have enough computing power to including all the related information into our model. For example, about the golden standard, there are some paper statistic because different result from different coder. So average, there are about 25% disagreement between different coder. Abbreviation, for example, like risk, you can be RNA-induced silencing complex, or it can also stand for reduced instruction set computed. Also, most of the hospital in Taiwan does not use the snowman CT concept. So for myocardial infarction, there are 6 different terms. So have 6 different description ID. If we use the single concept ID, this can be unified and the complexity can be reduced. Then I will give a result about our genes. Before 2018, last day. The pipeline duration is about 7 days. Okay, we only did the DNA extraction and quality control and final stage clinical reading in our hospital. Then we take the bearing colony back and parallelize the algorithm, so we can reduce the turnaround time from 7 days to 6 days. It's about 2 years ago. Now we move the sequencing machine into our hospital, so the total turnaround time can be reduced into 3 days now. This is the workflow of our bearing interpretation. After alignment and bearing coding, we developed a called Mviewer. It has a web application and a single user program. Firstly, we annotated my web ANNOVAT. Then we query different database like human genome gene mutation database, OMIM, Mendelian Inheritance in Man, Taiwan Biobank, CRINVA, also the Vivara, and we do the chart analysis. We filled out the unrelated bearing, and then we do the interpretation. Here, this is a bearing prioritizer, like we extract a keyword from the electronic medical record and use tool to transform to HP.12. Then we rank the candidate gene based on text mining from the PubMed text. And then we generate the gene ranking list. This is the HP.12, the standard form used in database. This is a case about infant with cardiomyopathy and metabolic acidosis. Is about 1 month old girl, shock and metabolic acidosis, and echocardiography, poor left heart ejection fraction, elevation of lactic acid, and the treatment, temporary treatment, is ventilation and cardiolemis. But we are curious about its etiology and any better specific treatment. Then after the whole exome sequence result in 7 days, we find out it's COQ4 homozygous mutation. So we get a better specific treatment as high dose coenzyme Q, and outcome, the baby girl recover very good, and then we have OPD follow-up. And this is the data description. We use the data collected by medical genetics and also the dbGaP database. This is our inclusion criteria. And this is more description of the data. And this is the inclusion of criteria and the needed information. And this is the detailed description about the bearing and causative bearing. This is the final result. Our result is the pink one. That is better than most of the others approach. like amelia, var erect, exomizer, phenolizer. This is our website for you to test. You are welcome to try. You can put in the bearing information and use the keyword from the EMR, and then you can search. This is our result, like for example, top 3 result. Okay. And this is complete, like for example, you put in the bearing file, and you put in the EMR, and we will extract the keyword for you, and then do the search to find out the causative variant. Okay, this is our conclusion about gene. For the 108 patient validation data, we succeeded in 92.6 cases to locate the causative variant in the top 10 ranking list. And I will give a very quick description of our lifestyle and environment. Okay, this is architecture for us to correct the lifestyle and environment data, including the airbox, the open data from our government, and also the data from the smartwatch worn by our patient. And then we build the platform and the database, also the analytic engine to correct and then to do the predictions. This is about our lifestyles data correction. We use Garmin and Fitbit. And so far, the data point is about 102.5 million. And this is about the environment data correction. We have data point about 6.3 million. And this is the app we developed to support the healthcare service. You can download from the Google Play and Apple Store. It's downloadable in Japan and Taiwan. And this is our smartphone applications. And we do an experimental care for COPD patients. The method is we include both lifestyle data, environment data, and the clinical data. Clinical data is using the MRC and the CAT questionnaire. The total case is about 185. The time interval is about 2.5 years ago until now. This is the final result. Like if we use just clinical questionnaire as the traditional approach, the F1 score is about 0.74. Use environment feature is about 0.9. Lifestyle questionnaire 0.83. If we include all the features, then we can reach 0.93. That's much better than before. The short conclusion is that we find out that change in lifestyle and environment can benefit the comprehensive management of COPD. We can achieve 0.986 on AUC/ROC on a task of predicting whether a patient is still suffer acute exacerbation within the next 7 days. Thank you for your attention.